Hey everyone, Mr. Skelton here. We're back at it. Lesson 3 in Unit 8. And today we're going to change gears slightly. You'll notice this first in the title, it says Arithmetic Series. So far in Lessons 1 and in Lesson 2, we did, I'll abbreviate, sequences, both arithmetic and geometric. Oops, geometric, spaced it out, sequence. So in Lesson 1 we talked about an arithmetic sequence, in Lesson 2 we talked about a geometric sequence, and now we're going to be talking about series. And in Unit 8 we call this lesson, or we call this unit, Sequences and Series. So we're kind of just changing gears about what the difference between a sequence and a series is. They are related, and we'll just talk about it right away. So we're going to focus, though, on arithmetic today, so you need to recall arithmetic. Remember, arithmetic has the common difference, D, common difference. All right, that's when we're adding or subtracting the same term, the same number over and over again. So that's what we're going to be focusing on today. So let's talk about what an arithmetic series is. A series, this is important, is the sum of all of the numbers in a sequence. So we still have the sequence here, 1, 2, 3, 4, 97, 98, 99, all the way to 100, and we're stopping at 100. But what I want to do with a series is add. Anytime you see the word series, that means you're going to be adding every single term within the sequence. This is still term number 1, term 2, term 3, term 4, all the way till we get to 100. But we're going to be trying to add these up. So before we talked about arithmetic series, if I asked you to add up all of these, you would probably take out your calculator, right? And you'd go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, all the way 10, 11, 12, all the way to 100. And that would take you a lot of time. So let's not do that. Let's try to figure out another way to add up all of these numbers. Now, I'm going to ask you to look for something. We're going to kind of derive this formula. It is a formula, and you can see it right here. This is the formula. But I'm going to show you how we got to this, okay? So I want you to take a look at the first term and the last term and add those up. What do you get? You get 101, right? Take the next term, 2, and the second to last, 99. What do you get? You get 101. Take the third term and the third to the last number, 3 and 98, you get 101. Take the fourth term and the fourth to last term, 97, and you get 101. Okay? And you could do this the whole way through, okay? And so what we want to figure out here, what we figured out is, okay, how many times is 101 represented in this sequence? Well, you're going to get to 50, 51 is going to be your last. When you add them together, you get 101. So you're going to have 50 101s, right? So you would take 50 times 101, because there's going to be 50 of them. So 50 times 101, and you get 5,050. And that is actually the answer to this problem. Now, if we take this thought and put it into a formula, this is what you get. This is called an arithmetic series formula. Okay? So let's just point out some of the important pieces of this formula, and it should make sense based on what we just went through here. A sub 1 is your first term, right? A sub n is the last term. So if you think about it, 1 plus 100. So what this is doing is creating that 101 pattern over and over and over again. Now, how many times do we get 101? Well, in this one we got 50. Well, how did we get 50? Well, there's 100 terms, right? This is the 97th term, 98th term, 99th term, 100th term. We did it 50 times, so that should make sense. However many term numbers there are, you cut it in half, and you get that pattern multiplied. So this is the formula. N right here means the number or total number of terms. So in this problem, we'd say sum of n equals 100, because we had 100 terms, divided by 2. First term was 1, plus the last term, which is 100. And so if you did it in formula form, that's what it would look like, and we'd still get 50 times 101, and we'd still get our 5,050. And that is how you do an arithmetic series. Okay? Let's turn it over. This is a pretty quick notes section. There's a lot of carryover from our sequence, arithmetic sequence notes, so this is going to be kind of nice, hopefully, for you. All right, so here's a situation. We got allowance. You're earning $10 for the first week, and then you're going to earn, your parents are generous, they're going to give you $2 more each week. Find the total amount of money you have earned after 1 year. Well, when I get a problem like this, I always like to write out the sequence first. So I started out with 10, and then that would be the first week. The second week, how much did I earn? I earned 12 because I added $2 more. The third week, I earned 14, right? Fourth week, I earned 16, ... Great. So we want to know after 1 year. Well, let's think about this for a second. We can't just start, some people will probably go, okay, I'm adding 2 to every term, right? I'm adding 2, I'm adding 2. So they figured out this is arithmetic because it's the common difference. But let's go to our formula. N over 2, a sub 1 plus a sub n. A sub n is the last term. So this series is n over 2. Well, what does n represent? The total number of terms. If we're talking about 1 year and we're talking about weeks, how many weeks are in a year? 52. So I'm going to have 52 terms. 1, 2, 3, 4, ... all the way to 52. So I'm going to have 52 terms over 2. We know my first term is a 10, but do we know the last term? We don't. You do from your arithmetic sequence lesson in lesson 1. How do we find this last term? Well, you need to go back to your explicit formula on how to find numbers within an arithmetic sequence. So what would that look like? Well, we got to figure it out, right? So we know we're going to have a sub n, or a sub 52, is going to equal, right? What's it going to equal? What our number that we started out with, our common difference times n minus 1. Okay? So we know that 52 is going to go in here, so our 52nd term started at 10 plus our common difference, 52 minus 1 is 51, and we're going to just take our calculator out and go 2 times 51, it equals, add that to 10, it equals, is 112. So what did we just figure out? We figured out that in the 52nd week, we're going to make $112 for the week for our allowance, which is pretty nice. The reason you need to find this is because in order to find this series, that number 112 has got to go there. And now we can figure out our sum. So we go 10 plus 112, it equals, and we're going to times that by 52 divided by 2, it equals, and we get $3,172. Not a bad haul for just doing your chores, okay? I would like you to try number 3 at the bottom, similar but yet slightly different to what we just did. I will tell you it does involve the explicit formula again, so hit pause and see what you can do. Okay, so here is our series. In your homework, they may ask you to translate this into a series. So this is a sequence, right? When you have the commas, that's a sequence. If they ask you to make it a series, you would just rewrite it like this, with plus signs in the middle. And some of the problems on the homework, I just don't want you to get confused. Oops, put a comma in there. So if they ask you to just write your sequence as a series, you just drop the comma sign and put the plus signs in there. That makes it a series, okay? And then I always like to write, try to figure out the pattern. Okay, that's plus 3. All right, that's plus 3. All right, good, I'm still plus 3. Good, first term, second term, third term, right, all the way. So we don't know what this is as the nth term. But I kind of get my basics down first and then try to figure out what I need. Find the sum. So I usually start with the formula, right? So I'm going to have my formula, which is n over 2, a sub 1, plus the last term, which is a sub n. Okay? And I just fill in what I have. So do I know how many terms I have, total terms? No. I know what the last term is, but I don't know the total term. So right now I have n over 2. I have the 50, because that's my first term, a sub 1. And I have my last term, which is 299. What we need to figure out is how many terms there are. Well, you did this back in your arithmetic sequence notes. So we use our explicit formula, right? So a sub n, because we want to figure out how many terms there are, is the first term, so a sub 1, plus the common difference, times n minus 1. That's the formula. I didn't put that in the previous one. Now let's figure out what we need. That's 50 plus the common difference is 3, okay? And then n minus 1. Now, we don't know what n is, but we know what n, or the nth term, that last term equals, so we would plug in 299 here, and we want to figure out what term number is 299. That's what we're trying to figure out so that we can plug that in right here. So we solve this, right? So I'm going to minus 50. So 299 minus 50 should give you a nice, neat 249. And then I'm going to divide by 3. So 249 divided by 3, I get 83 equals n minus 1. And then I'm just going to add 1 to both sides. And I'm going to get 84 equals n. So what does that mean? What did we just find? We just found that there are 84 terms in this series or sequence. Why is that important? Well, because we need to plug that in right here for n. Because remember, n represents the total number of terms in the sequence. So now this becomes 84 over 2, 50 plus 299. And we just take our calculator out and go 50 plus 299. And then we're going to times that by 84 divided by 2. You can obviously do that in your head. And we should get 14658. So 14,000, it's not money, it's just 14,658. Okay? So a couple quick examples there for you. We only did 3, but again, I think that those are all encompassing of what you're going to see on your homework for arithmetic series. All right? Look forward to seeing you in class. Let me know if you have questions.